Hello, Jeremiah. I just thought it'd be easier for me to answer your questions with a verbal explanation than to try to type it out because I want to make sure you understand. Question 7 on the quiz, I'm reading through that. This is a brand new curriculum this year. I think I'm going to write that one up because I don't like the question. You are correct in that the question itself is actually faulty. So, what they're trying to get you to realize is that it is the rotation of the earth that causes day and night, right? So, the answer to the question is the earth itself. However, as the earth revolves around the sun, it is going to experience sunlight on various sides of the earth. It's just going to be a very long day and a very long night. So, the only way in which the earth could be plunged into eternal darkness on half the world would be if it's like the moon in that the moon actually has what we call synchronous rotation with the earth. It revolves at the same rate that it rotates, so it's tidally locked to the earth, right? If that happened with the earth and the sun, then yes, half the earth would be eternally dark and half would be um, eternally in the light. Um, yeah, the anti-rotation machine I think is not the correct way to word this, and I'm going to write that question up so that they fix it because the question itself is faulty. Now, let me see the second part of what you are saying here. Um, Question 11. Let's see here. Huh. Yeah, it's also just a bad question. So again, I'll write this one up. You are still correct in that it's a solstice. They want you to say the earth is close to the sun, which is false. The earth is actually farther from the sun in the summertime. I appreciate you bringing these to my attention. It's just like with biology last year and how it was a brand new curriculum and I had to write up some of the questions. Now, as far as your understanding, let's talk about that for a moment. So the sun is, the Earth has an elliptical orbit around the sun, but the ellipse is actually very, very slight. It's almost completely circular. I'm trying to draw it, but my drawing skills are like not the best. So that's a look a bad little egg there, right? So it's almost like like a perfect circle. So at one point, the Earth is like a little bit closer to the sun in what we view as the winter for us, right? And a little bit farther away in our summertime. The distance, the distance difference between winter and summer from the sun is very small. It has a negligible effect on temperature. It really doesn't have much of an effect on temperature, obviously, because seasons being what they are, it's much warmer in the summer for us, much colder in the winter for us, right? So we know that that's not really what is causing seasons. What causes seasons is the tilt of the earth. So during the summertime, even though we're further away, we are angled in such a way that the most direct rays of the sun are reaching the northern hemisphere. Therefore, it's the hottest there. The sun is actually providing more energy per unit of area. In the wintertime, even though we are a little closer, just a little closer, the most direct rays of the sun actually hit in the southern hemisphere, not the northern hemisphere, right? During the spring and fall, the most direct rays are hitting at the equator. So it's not the distance from the sun as much as it is how direct the sun rays hit. When sun rays hit something straight on, right? So that means that the sun rays themselves are able to heat a smaller area and they don't get spread out as much. Let me see if I can show you a picture of that. Let's see. Okay, so a good example is this picture right here. I'm gonna see if I can paste it in here. So here is like the sun rays hitting a surface straight on. Notice that the rays themselves, they heat this area right here, right? Right where this red line is. All the energy of the sun is concentrated into just this area. When the sun's rays strike at an angle, the area that they have to heat is larger. So the sun rays themselves, um, it's the same amount of energy, but it's heating a larger area. Therefore, it doesn't feel as warm. So if you can kind of use an analogy as like this, in this analogy, it's like taking a heater and putting it into a bathroom. It can get very hot in that bathroom because the bathroom is very small. But if I take that same portable heater and I put it in a gymnasium, even though it's the same amount of energy, it's got to heat a much wider area. Therefore, you don't feel the heat as much because it's spread out over a much larger area to heat. So, this is what the sun's rays are doing in the northern hemisphere in the summertime. This is what they're doing in the northern hemisphere in the wintertime. So yeah, that's the explanation. But for that question, go ahead and pick a solstice because the Earth is very close to the sun. And I will write those two questions up and make sure they get fixed. And if you notice anything else that seems a little bit suspicious, sus, or whatever, let me know because sometimes the people who write these quizzes, I don't know if they have the expertise in this area, unfortunately. But I want to make sure that we get them fixed for other students. So thanks a lot, Jeremiah. I hope that makes sense. And let me know if you have any other questions.